Hi, my name is Devendran. In this video, I'm going to discuss about my project. The title of my project is a prototype of solar energy steam powered turbine generator for rural areas. Okay, well, discuss the. I will summarize the project. Okay, this project's concept is to absorb heat from the sunlight and transfer the heat to generate uh, steam through a parabolic reflector. Then the steam will be transferred to a steam turbine to produce rotation over there, and that rotation will be transferred to a generator through a belting system, and then the generator will produce electricity. Then the steam that we use to generate, I mean, to create rotation at the steam turbine will be cooled down back, and it will turn back to a water molecule and water form. Then the water will be reused back to generate steam will be stored, and then the water will be reused back again. Okay, through this problem, actually what kind of problem we can solve it is, as we can see, the aim of this project is to use at the rural area, because at rural areas it's very hard to get electricity, because electricity is a basic need for every one of us. And at rural areas, since I said earlier, getting electricity at there is quite difficult. If they want to get supply through a transmission line, is very difficult, because transmission line had to go through difficult path and all. They have to go through hills and all. So the setup for transmission line is very costly, and if they choose renewable energy method to get electricity over the area, few renewable energy, they do have many kind of disadvantage, like solar panel. After some time, they'll I mean, we have to change the panel, and if let's say they want to go for hydro power plant, then they have to change the river flow. That will affect the agriculture and all. So this is what this project, I mean, this prototype will solve this kind of problems and all. Okay, next I will show the design of this project. So we had to fabricate two main components for this project. One was the parabolic reflector, another thing, it was the steam turbine. Okay, was our parabolic design. So this is the reflector, the film, and the middle one is the fill pipe. So this is what we will place on the sunlight, and then it will produce the steam, and that steam will be transferred from this pipe to the turbine, and it will go to the turbine. It will spin, and it will lift the turbine, and will go to the cooling coil, and it will get cold, and well, the water will be stored again, as I said earlier. Okay, so okay, uh, we can see that these are the results for our for what we got from our prototype. So there are three different pressure releasing pressure that I have tested. One of that, they were 40 psi, 50 psi, 60 psi, and for 40 psi, for 40 psi, the maximum power I got was 4.394 at for the last reading. I think you can see the 4.394 watt I got through that at 3:30 p.m. on 22 September 2020. On the day climate, it was 33 degrees Celsius. So that is what I got, and that time the temperature on the parabolic mirror also were taken, and that was 118 degrees Celsius. And next, the second day, tests were done on said the second test was done on 23rd September 2020. On the day, the maximum current I got, I mean, the maximum power I got on the day was 5.22 watt at 1 p.m. At that time, the temperature on the parabolic mirror, it was 117 17.4 degrees Celsius. So on the day, the climate was 32 degrees Celsius, the climate weather temperature. And the last, we were tested on a releasing pressure 60 psi. So on the day, we got 5.772 watt. That was the maximum power we got on the day. And next, on the same day, the time was 120 p.m. 1:20 p.m. And at the time, the parabolic reflector temperature was 106 degrees Celsius. This was taken on 24th September 2020. On the day, the climate temperature was 32 degrees Celsius. And these are the results we got through this parabolic. I mean, this about from this prototype. Next, okay, what are the new from for compared to the market, I mean the existing renewable energy. So this is a new concept because the existing prototypes all are in a large scale. So this is in a small scale and it is in a small size, so it doesn't require a big amount of space to operate. Okay. And the potential of application and commercializing is the this is a solar energy steam powered turbine generator. This concept operation was successful, and commercializing potential was it is suitable to use at rural areas, and it doesn't require big amount of space to operate, as I said earlier. So this is my, I mean, generally this is what this prototype is about. Okay, that's all. Thank you.